So this is solving rational equations. I'm going to kind of start it out how I would combining a addition problem, how we've done in the past. I'm going to find the LCD. But this time, instead of making the two fractions the same and doing some kind of weird stuff, it's easier to then multiply each fraction by the LCD. By multiplying, I'm going to get rid of the fraction. I'm not going to have a fraction anymore. That's way easier to deal with. I'm going to end up with a linear equation or a quadratic equation, and we know how to solve those. So here, I can make 2 into a fraction by writing it over 1. Then I have an x, a 1, and an x. So I'm really just comparing x and 1. X and 1 have a 1 in common, but 1 needs an x. So my LCD is x. That should be step 3. Step 2, I'll just say step 2 is find LCD. Step 1, find the excluded values. The excluded values we said in the past was when the denominator equals 0. So if I have 5 over x, I'm going to look at my denominator and set it equal to 0. Well, x equals 0 when x equals 0. So I'm going to say x cannot equal 0. So x can be whatever number it wants, but not 0. And this is going to make a lot more sense when we actually get into graphing these, like what their limitations are. So I'm going to multiply each fraction by x. And so if I have an x on top and bottom, it's gone. That one's okay. Here I have an x top and bottom, so that's gone. So I'm going to rewrite it. 5 plus, and I have 2x equals 6. And now I have a normal equation I can solve. And then I'm going to find x and then compare it to the excluded value. I'm going to rewrite this. So now I need to find x. I need to rearrange my equation to get 5 on this side. So I have 2x equals 1. So 2x equals 1, divide by 2. I get x is 1/2. My last step, compare it to the excluded value. So 1/2 is not 0, so I'm good. The solution is x equals 1/2. And there's an example where the solution is the excluded value, and we'll get to that. But right now, all I care about, it is not the excluded value, so we're good. On this one, I have something to factor first. So I got a factor x squared plus x. X squared and x have an x in common. So x times x is x squared. X times 1 is x. So then I look at it, I have an x, x plus 1, x plus 1, x. So my LCD would be x, x plus 1. And my excluded value, if I set x equal to 0, x cannot equal 0, and then x plus 1 equal to 0, x could not be negative 1, because x plus 1 would equal 0 when x is negative 1. Negative 1 plus 1 is 0. So x can't equal 0 and it can't equal negative 1. So now I'm going to multiply each fraction by x, x plus 1. So this one, if I multiply x, x plus 1, it totally cancels and leaves me 3. This one, the x plus 1 would cancel and leave me x, so I have 3x. And this one, I have an x, so it'll leave me negative 1 times x plus 1. So negative x, negative 1. So I have more x's on the left. So I'm going to add x, subtract 3. So I have 4x equals negative 4. So divide by 4. Negative 4 divided by 4 is negative 1, and I get x equals negative 1. But what do we say x cannot be? 0 and negative 1. So I gotta throw it out. So if the only solution I could get isn't possible, I'm going to say no solution. So this equation has no solution. In the next one, we've seen something like this before. When we're trying to factor, it's most likely going to have a denominator in common, or a factor. The denominators are going to have a factor in common. So if it was an x minus 2, I have to figure out what the other number is. It multiplies negative 10, adds to 3. So that'd have to be a 5. 5 times negative 2 is negative 10. 5 plus negative 2 is 3. So they all have an x minus 2 in common. But my LCD is what is common, what is not common. So x minus 2 and x plus 5 is not common, so that's my LCD. X minus 2 would equal 0 when x is 2. X plus 5 would equal 0 when x is negative 5. So I gotta multiply each fraction by x plus 5, x minus 2. So x minus 2, I'll be left with the x plus 5. Same for this one. But this one has both, so I'm left with 6. So I multiply 2x plus 10, x times x times 5, and then since I have a quadratic, I gotta set it equal to 0 and factor. So 0 would equal x squared plus 3x minus 4. So multiplies to negative 4, but adds to 3. Be 4 and a 1, it would be 4 and negative 1. And 4 and 1, regardless of if it's positive or negative, is not a 2 and a 5. So I should be good on my solutions. So I change my sign, so it's x plus 4, so it'd be x equals negative 4. Then minus 1, x would be positive 1. This one, both denominators are factored, but they have nothing in common. And so my LCD would be x plus 2, x minus 2. Well, I said they have nothing in common. They have a 1 in common, which that doesn't help. So the x plus 2 would cancel out x minus 2. This one, I'd be left with an x plus 2. And then on this side, I'd have both, since nothing would be eliminated. So I'd multiply. X squared, I'd have a plus 2x, a minus 2x, so I would not have any x's left over. They would add to 0. Then positive 2 and negative 2 multiply to be negative 4. So now I need to start collecting my like terms. So an x squared, I have a negative 2x minus a 4x. Then I have minus 8. I have 2x squared minus 8. So I have more x's on this side, so I'm going to get everything over here. So subtract 8, add 6x, add 8. So my 8's would go away. So I'd be left with x squared plus 6x equals 0. So x times x is x squared, x times 6 is 6x. So it means x is 0 and x is negative 6. If I look back at my original, my denominators would be equal to 0 when x was negative 2 and positive 2. So neither of the x values that I got from solving were the excluded values, so these are both my answers.